Hello students, I'm Sir Gary and welcome to our video lesson. And today, our lesson is all about zeros of polynomial functions. And at the end of this lesson, you are about to find zeros of polynomial functions. But before that, let's have a short recall.
Match each polynomial according to its factors. You have 10 seconds to answer and your timer starts now. Alright, time is up. Let us now factor our given polynomials. Let's have first the factors of 4x cubed minus 25x squared plus 6x. If this is your answer, you are correct. Next, what is the factors of x squared minus 36? If this is your answer, you got it right. And last, the factors of 25 minus x squared is the quantity of 5 plus x times the quantity of 5 minus x. Good job, students! To begin with, let us know what is zeros of polynomial function. It can be shown that for a polynomial function of degree n, the following statements are true. The function has at most n real zeros. The graph has at most n minus 1 turning points. Example, x cubed plus 4x squared minus x minus 4. As you can see, the highest degree in this example is 3. So our n minus 1 will become 3 minus 1 equals 2. Therefore, the turning point of a cubic polynomial function is 2. Also, turning points, relative maximum or relative minimum are points at which the graph changes from increasing to decreasing or vice versa. The zeros of a polynomial function are the values of x which make function of x is equal to 0. These values are the roots or solutions of the polynomial equation when y is equal to 0. All real roots are the x-intercept of the graph. Also, the rational zero theorem helps us to narrow down the list of possible rational zeros of a polynomial function. Let's have our illustrative example 1. f of x is equal to x cubed plus 3x squared minus x minus 3. By means of rational zero theorem, these are the possible factors. We have positive or negative 1 and positive or negative 3. At this point, we will use synthetic division to evaluate each possible zero until we find one that gives a remainder 0. Let's begin with negative 1. Negative 1 divided by 1, 3, negative 1, and negative 3. Bring down 1, and 1 multiplied by negative 1 will give us negative 1. Just add them. 3 plus negative 1 will give us 2, and 2 multiplied by negative 1 will give us negative 2, and negative 1 plus negative 2 will give us negative 3. Negative 3 multiplied by negative 1 will give us positive 3, and negative 3 plus positive 3 will give us 0. We can now rewrite f of x as x plus 1 times the quotient, and we get quantity of x plus 1 times the quantity of x squared plus 2x minus 3. As you can see, the quadratic polynomial function is factorable. Therefore, the quantity of x plus 1 times the quantity of x plus 3 times the quantity of x minus 1. At this point, we will equate these factors to 0. Therefore, x plus 1 will become x plus 1 is equal to 0. Next, subtract both sides by 1. Therefore, x is equal to negative 1. Next is x plus 3 will become x plus 3 is equal to 0. And subtract both sides by 3 and will become x is equal to negative 3. Next is x minus 1 will become x minus 1 equal to 0. Add both sides by 1 and will become x is equal to 1. Therefore, the zeros are positive 1, negative 1, and negative 3. These are the x-intercepts. and the y-intercept is negative 3. The degree of the function is 3. The graph has 2 turning points. Next, let's have our illustrative example 2. F of x is equal to x cubed plus 2x squared minus 5x minus 6. By means of rational zero theorem, these are the possible factors of our given function. We have positive or negative 1, positive or negative 2, positive or negative 3, and positive or negative 6. And at this point, we will use synthetic division to evaluate each possible zero until we find one that gives us remainder 0. And now, let's begin with negative 1. Negative 1 divided by 1, 2, negative 5, and negative 6. Bring down 1. 1 multiplied by negative 1, we get negative 1. Just add 2 plus negative 1 will give us positive 1. Just continue the process until we get to 0. Now, we can rewrite f of x as x plus 1 times the quotient, and we get quantity of x plus 1 times the quantity of x squared plus x minus 6. At this time, our quadratic polynomial function is factorable. Therefore, quantity of x plus 1 times the quantity of x plus 3 times the quantity of x minus 2. Same process, we will equate these factors to 0. Therefore, x plus 1 will become x plus 1 equals 0. Just subtract both sides by 1. Therefore, x is equal to negative 1. Next, x plus 3 equals 0. Subtract both sides by 3 and we have x is equal to negative 3. Next, x minus 2 is equal to 0. Just add both sides by 2 and we have x is equal to 2. Therefore, the zeros are negative 3, negative 1, and 2. These are the x-intercepts. The degree of the function is 3 and the graph has 2 turning points. Next, we will have the multiplicity of zeros. It tells how many times a particular number is a root or zero of a given polynomial. For the characteristics of multiplicity, we have odd and even. And for the behavior of the graph relative to x-axis, for odd is cross the x-axis. And the graph changes from the positive to negative or vice versa. And for even, tangent to x-axis. The graph is either positive on both sides of the root or negative on both sides of the root. Let's have an example. Given the function of y is equal to x plus 1 times the quantity of x minus 2 raised to 2 times the quantity of x plus 3 raised to 3 and its graph. Complete the table below. For our roots or 0, we have negative 1, 2, and negative 3. And for our multiplicity, we have 1, 2, and 3. And for the characteristics of multiplicity, odd or even, look at our roots. Our roots here is odd. Therefore, the characteristics of multiplicity is odd. Next is even. Next is odd. Behavior of the graph relative to x-axis in this root, crosses or tangent. As you can see, the characteristics of multiplicity is odd. Therefore, it crosses to x-axis. Next is even. This means tangent to x-axis. Next is odd. Therefore, it crosses to x-axis. Let's find out the graph of our given function. This is the graph of our given function y is equal to the quantity of x plus 1 times the quantity of x minus 2 raised to 2 times the quantity of x plus 3 raised to 3. For our negative 3, as you can see, it crosses to x-axis, same as to our negative 1. And for our positive 2, tangent to x-axis. Remember that the graph touches the x-axis is tangent point. Now, let's have a review. Find the roots or zeros of f of x is equal to x squared plus x minus 12. A. 3 and negative 4. B. 4 and negative 3. C. Negative 4 and negative 3. D. 3 and 4. If this is your answer, you are correct. The factors of x squared plus x minus 12 is the quantity of x minus 3 times the quantity of x plus 4. Equate them to 0, it will become x minus 3 equals 0, x plus 4 equals 0. And x is equal to positive 3 and x is equal to negative 4. Therefore, the roots or zeros are 3 and negative 4. Next, what are the zeros of the function? Quantity of x minus 3 times the quantity of x minus 7 times the quantity of x plus 5. A. Negative 3, 5, 7. B. Negative 7, 3, 5. C. Negative 5, negative 3, and negative 7. D. Negative 5, 3, and 7. If this is your answer, you got it right. The quantity of x minus 3 times the quantity of x minus 7 times the quantity of x plus 5, equate them to 0, and we get our zeros. X is equal to 3, x is equal to 7, x is equal to negative 5. Therefore, the zeros are negative 5, 3, and 7. Next, in the function of m of x is equal to x squared times the quantity of x plus 3 times the quantity of x minus 3 times the quantity of x plus 4, which 0 has a multiplicity of 2. A. Negative 3. B. 0. C. 3. D. Negative 4. If this is your answer, you are correct. The exponent tells us the multiplicity. X squared is equal to 0. Therefore, x is equal to 0 to the multiplicity of 2. Let's have our generalization. The graph of zeros of polynomial function has at most n minus 1 turning points. Synthetic division can be used to find the zeros of a polynomial function. The exponent tells us the multiplicity. Next, characteristics of multiplicity is odd or even, and the behavior of the graph relative to x-axis of odd is crosses to x-axis, while the even is tangent to x-axis. And that's all for today. I hope you learned something. Thank you and God bless. Stay safe.